Welcome to our senior secondary chemistry series. In this video, we're going to take a look at solutions and crystals. So here are the learning outcomes. At the end of this video, I expect all of us to know all the terminologies associated with solutions. We're going to learn about solutions and we're going to learn the terminologies that are associated with solutions. Most of the concepts that are involved with solutions, I'm sure most of us are well acquainted with. And of course, the job will just to know some of the technologies. For example, when you mix sugar and water, when you're making ziggy, scientifically, how do we call the sugar and how do we call the water? I expect you also to be able to tell types of liquids in terms of solubility. I expect you to be able to state factors that affect solubility of a gas or gases. You're going to understand all these points when we start studying, but at the end of the day, you should come back here and check if you have attained these objectives. Finally, I expect you to explain the process of crystallization. So we're going to learn about what is called crystallization. So you should be able to explain this process. So this topic is concerned with zig. You are going to study zig. What is zig in English? When we were young, they used to say that it's solution. Yeah, but I was watching an American movie where it was called sugared water. So I think that's the closest word we can use for zig. Anyway, we're going to study solutions in here, which is just mixture of things. And most of the processes that are going to be discussed, we are already familiar with. So what you're going to learn or what you're going to concentrate on are the terminologies. We learned about the three states of matter. We learned about the chemical constituent of matter. What's the nature of chemicals that makes up matter. And we learned about the kinetic theory and whatever it states, the suggestions. So here, before we can study the chemicals that makes up matter any further, here we're going to discuss what happens when matter is mixed with matter. What happens when solids are mixed with liquids? When liquids are mixed with gases, what happens? So we're going to start with solids and liquids. What happens when solids are mixed with liquids? We're going to start our study with this here. So I've got a cup here with water. Let's say we've got sugar cubes, or it can be salt cubes, whichever you like. So if you throw them in here, they will dissolve. We all know that they will dissolve. If you want, of course, you can stir, but at the end of the day, they will dissolve. So the cubes, the sugar cubes, or the salt crystals, as they are called, the salt cubes, whichever you like, they are solid in nature, and water is liquid in nature. So I've mixed a liquid and a solid, and what happens is one dissolves in the other. So one of these is called a solvent, which is defined as a substance in which another dissolves in. In this case, it's water. So water is our solvent. Then the other is called a solute, which is defined as a substance which dissolves in another. So these are terminologies, like I emphasized at the beginning of the video, that we're going to concentrate on the terminologies. You know that these things, the dissolving, you know how it happens. So what you need to know is the scientific terminologies that are used to describe the various parts of solutions. We can continue. So the whole mixture, that is the mixture of sugar and water, is called a solution, which is defined as what is formed when one or more solutes dissolve in a solvent. So the definition says one or more because it's possible that you can throw both salt and sugar in that water. So the salt is the solute and the sugar is the solute. At the end of the day, you still have a solution. A solution in which after mixing the two or more substances, you can't tell what makes it up. It looks like it's one thing. It's termed to be a homogeneous or uniform mixture. So any solution in which the end product, the result, you cannot tell the constituent or the things that makes up it is called homogeneous or uniform solution or mixture. For example, if you look at this water, you cannot tell if there's sugar or not. Of course, when you're making zig, the color might change a bit, but still you need the experience to tell that there is zig in it. So this is one of the terminologies, homogeneous or uniform mixture or solution. A solution in which water is a solvent is called an aqueous solution. So whenever water is a solvent, the solution is termed to be aqueous solution. So what happens if we throw a piece of chalk in water like this? Will the piece of chalk dissolve? No, it won't dissolve. What can we learn from this? Not all solids dissolve in water. Some solids don't dissolve in water. So there is a new word that we need to acquaint ourselves with, and the word is solubility. What is solubility? Solubility is defined as a substance's ability to dissolve in a liquid. So different solids have different solubilities. Different substances have different solubilities. A substance that dissolves in water is termed to be soluble. So salt and sugar are soluble, well, chalk is not soluble. And this is defined as a substance which dissolves in a liquid, like I said. Then, of course, chalk is insoluble, and the definition is a substance which does not dissolve in a liquid. So, there is another term which we can name, and it's called suspension. Let's say we throw a powder of chalk or chalk powder in the water. If you can look closely, our water looks cloudy now because somehow, without you noticing, I have thrown some powdered chalk in it. Anyway, it looks a little bit cloudy. When you throw, let's say, meal in water, the water will appear cloudy. Same as when you throw chalk or powder of chalk or powdered chalk, so to put it, in water, the solution will appear cloudy. Such a mixture is called a suspension. So what this means is there are small particles of meal if it's meal or chalk if it's chalk powder, which are suspended in the solvent and not dissolving. So such is called a suspension, and it can be defined as the cloud mixture of an insoluble solid and a liquid. Also, it is termed as heterogeneous mixture because, or an uniform mixture if you prefer. This is because the end product, you can tell that it's made up of two different things, unlike homogeneous mixtures. So these are the terms: solubility, soluble, insoluble, suspension, heterogeneous mixture. So we have looked at what happens when solids are mixed with liquids. Some solids dissolve in liquids and are said to be soluble, while others do not dissolve and are said to be insoluble. We are going to look at what happens when liquids are mixed with liquids. Are we going to observe the same thing of dissolving or not? So we're going to start the study with, as usual, our cup with water in it. So what happens when we pour alcohol in this cup? I know most of you might not know what alcohol is because you are school children or yeah, Manawa school in English is school children. Yeah, so most of you might not know what alcohol is, or an example of an alcohol that you can imagine which can be poured into water. But at the end of the day, when you pour water into alcohol, the resulting mixture or the resulting solution is uniform, which means at the end of the day, you won't be able to tell the constituents of the solution or what makes up the solution. Such liquids, which if mixed gives you a uniform solution, are called miscible liquids, and defined as liquids that mix forming a uniform solution, just like I said. The opposite are called immiscible liquids. So imagine you get paraffin or kerosene, or maybe cooking oil, or as we call it in Zambia as salad, in Zambian English, of course. So if you pour salad into water, you'll be able to tell that there is salad in there. The resulting mixture will have two layers, one of salad and the other one of water. Such a solution, which is not uniform, is, as we said, it is an heterogeneous mixture, an heterogeneous solution. Liquids that form such a non-uniform solution are said to be immiscible liquids, and defined as liquids that mix forming a non-uniform or heterogeneous solution. So to give you a picture of what I'm trying to describe on how you can tell that this liquid is immiscible, that these liquids are immiscible or these liquids are miscible, is the resulting solution will look like this. There will be a layer like this one here, which will tell you that this is something else, and the top layer which will tell you that this is something else. So for the example that I gave, which is cooking oil and kerosene, you see a layer of kerosene or cooking oil on top of the water, and that's when you can tell that these two are not miscible, or they are immiscible liquids. So that's everything about liquids and liquids. The next thing we're going to concentrate on, maybe the last, is what happens when a gas is put into a liquid. What happens when you put oxygen into liquids? Or maybe the good question to ask is, how do fish breathe? Since there are no gases in the water, so how do fish breathe? Of course, gases dissolve in water. Most of the gases actually dissolve in water. That's the reason why fish breathe underwater. Because of that, because most gases dissolve in water, we're going to look at what factors determines the solubility of a gas. In short, what determines how soluble a given gas is? Gases have different solubilities. So what factors determine the solubility of a gas? The first factor is pressure. Pressure is defined as force per unit area. Don't worry about the definition of pressure. It's something that you learn in physics. But what I'm trying to say is, pressure is some force that is applied somewhere. When you say, nina pressure, what you mean is there is force that is being applied on you. So let's say this is our liquid here, and we've got some gas on top here. And how do we apply pressure? So if we can cover this cup here, and then we start pushing whatever is covering the cup down, the gas that is occupying this empty space will dissolve in water. So that's pressure. From here we can conclude that the higher the pressure, the greater the solubility. You increase the pressure, solubility increases. You reduce the pressure, solubility decreases. Another factor that determines the solubility of a gas is temperature. It is common knowledge that solids dissolve faster in hotter liquids, or when the temperature is high. We say that sugar dissolves faster in hot tea than in ziggy. But for gases, it's opposite. gases dissolve more in cold water. And from that, we can conclude that the lower the temperature, the greater the solubility. That factor is the nature of a given gas. So by nature is the type. In terms of nature, gases can be classified into three. And these are acidic, alkaline, and neutral gases. We will then what an acidic, alkaline, or neutral substance is. But for now, you can picture an acidic gas as a gas that has got some properties of an acid. Any acid that you know, it can be battery acid or anything. Then alkaline is the opposite of acid. Any substance that is said to be alkaline, it's just the opposite of acid. In short, it behaves opposite to an acid. Then a neutral gas, it's a gas that is neither acidic nor alkaline. And when it comes to solubility, acidic and alkaline gases are more soluble than neutral gases. Neutral gases are said to be slightly soluble. Let's move on to what is called a saturated solutions. A saturated solution. So what happens when you put sugar in a cup and you stir? The sugar will dissolve. And if you put more sugar and you stir again, the sugar will dissolve. At some point, the sugar won't be able to dissolve, regardless of how much sugar you put or how hard you stir. A solution which cannot dissolve any more excess solutes is called a saturated solution. So the point when it has stopped dissolving excess solutes, that point is called a saturation point. So a saturated solution is a solution which cannot dissolve any more solutes when solutes are in excess. The opposite of this is called unsaturated solution, which is defined as a solution which can dissolve more solutes. So initially, when you had put sugar into that water and the sugar could dissolve, that was a solution in its unsaturated form. But as you kept on adding sugar, a point was reached when the solution became saturated. So why are we learning about saturated and unsaturated solutions? This is because there is something interesting that is observed in nature that is formed from saturated solutions. That thing is called a crystal. This is how crystals look like. So these are crystals. I'm sure you have seen one of these. I remember this one when we were young, we used to have fun with it. But for those who have never seen a crystal before, I'm sure you have. Salt is a crystal. Salt is a crystal. So what is a crystal? Maybe we know the definition. So a crystal is defined as a solid that consists of particles arranged in an orderly and repetitive manner, resulting in a regular shape. That is what a crystal is. How does a crystal come about? Where do they come from? How are they formed? So the process by which crystals are formed is called crystallization. There are three ways in which crystals can be formed. But first, they come from a saturated solution. So if you want to form salt crystals, this is a simple experiment which you can do in your kitchen. Just put a lot of salt in water, then stir till all the salt dissolves. Keep on adding salt till the water can no longer dissolve that salt. Now that you have attained a saturated solution, the next thing to do is to you can try out three things. The first is you can cool that solution. When you cool that solution, some crystals can be seen inside the solution. The other way is to evaporate till all the solvent evaporates. So you put it on something like a stove or anything that can heat your solution. Then make sure that all the water, all the solvent evaporates. What will remain are the salt crystals. The last way in which you can form crystals from a saturated solution is you evaporate it slowly at room temperature. Room temperature is just the normal temperature. So you can just get your solution, you put it anywhere, then you let it you let the water evaporate. If it can evaporate, what you're going to get at the end of the day are crystals. To give you a visual understanding of how crystallization comes about, let's say I've got this cup and it has water, and let's say we start heating this cup. So as the water will be evaporating till we have no more water, the result will be crystals. So what do these crystals come from? Those salt particles that are dissolved, or sugar particles that are dissolved, they were inside the liquid, but they were not visible because they are dissolved. So once you heat, only the liquid will evaporate. Those things which were hiding inside the liquid, inside the solvent, will still be there. So when all the solvent evaporates, what will remain are the particles which we see as crystals. So this marks the end of this video. Make sure you like, subscribe, and share. You can use the comment section for clarification. Otherwise, happy solving.